Okay, so today we're going to be talking about functions. So we're going to be doing a Nearpod. So let's go through this. There's a student-based one embedded in the Canvas. If you're in class, we'd go over it together. But if you're at home, pay attention. I'll go through what this is on this Nearpod and how it look. Okay, so this slide is just a video. If you're at home, watch it. If you're in class, we would project that and just watch it together. That goes over basically what a function is. It's pretty good. It's a good video. Okay, then we've got a bunch of simulations, interactive simulations to kind of describe what a function is. So again, a function is basically just like you put something in and it outputs something, right? So this is a visual function machine, whatever you want to call it. So for example, it has a bunch of transformations we can do to these objects. So let's use this mirror one, for example. If I do a mirror and I input this person, you'll notice that it outputs that person mirrored, right? Same thing with this, or sorry, you wouldn't really be able to tell with the butterfly, but let's try the feet. Yeah, they're facing the other direction, right? Just changes their direction. If I try this wheel, it's going to rotate my images. So again, if I try with this dude here, he goes the other direction, right? If we try the camera, it changes them to black and white. Let's try this rainbow. I don't even know what this one does. Changes their colors somehow. Oh, it inverts their colors. Okay. I don't know what this one does. Does it do anything? Not that I can tell. Anyway, something to play around with on that one. The next one gives me some actual math functions here. So if I put in like a +3, and let's do a times by 2. Okay, so basically if I input a number here, it's going to add 3 to it and then times it by 2. So if I input 0, it would add 3 to it and then times it by 2, you get 6. If I input 2, that would add 3, which would be 5, and then times by 2 should be 10, right? So it's just putting those inputs and outputs. Again, for each number I input, there's only one output, right? If I put in 3, it's not going to give me 12 and 6. Those are two different outputs. Okay, so again, something to play around with. You can hide it, maybe have somebody you know mess around with it. This allows you, and again, we can spit them back out. So if I go through this again, I added 3 to it, right? And then I times that by 2. So you can kind of confuse people because they might think it's adding by 3 each time, right? But if you put in 2 or 1, like it becomes obvious. So I put in 2, you get 5, 10, whatever. Okay, something, again, more stuff to play around with. This one you can make your own and then plug them in. And then on this one, you have to figure out what's going on here, right? So if you want a challenge, you can do 3. So if I plug in 0, let's see what I get. I get 4. So I can kind of see, there's a graph. That's my table. So if I want to be able to guess what it is, plug in 1, I get 5. Well, it looks like they both went up 4 each time. Plug in 2, I get 6, which also went up 4. I bet that when I plug in 3, I'm going to get 7. And I did. And if I want to figure out what's happening, it's adding 2, it's adding 4 basically, and timesing by 1. So that's not that tricky of one. So if I try 0, -2/3, that one's going to be a little bit trickier, right? Plug in 1, I get -1. Plug in 2, -4/3. Okay, so then you can kind of guess what it is, and then when you want to check your answers, you can check what the actual thing is there. Okay. Then we're going to be talking about function notation. I don't know what this business is. Function notation is just another way of writing equations. It reads as f of x, and basically it's saying that the output of f or the input of x, this x or whatever's in the parentheses is your input, and it's just f is like the name of the function or your output. Okay, so basically when you're looking at this in equation form, y equals 2x minus 3, again, x is usually your input with equations. The function notation, you're just replacing the y basically with fx. It serves the same purpose. It's your output. Basically, fx is representing your output. Okay. So for example, we're going to do a little draw here. If I want to find f of 3, I'm going to replace the x with 3, right? Because f of 3, I'd replace my input with 3. So I would have 4. Can I draw on here? I would have 4 times 3, and then I don't remember, it was plus 2. And 4 plus 2, right? So 4 times 3 is 12, plus 2 would be 14. So the output would just be 14. Basically, that's what we're doing here, is we're just trying to plug things in for x right here, right, with whatever numbers in parentheses. Okay, if you have any questions, ask your teachers. We're here to help. We want to help, and I will see you guys out there.